Hello, this is Bhavani, Assistant Professor in IT Department at SMIT. We are going to see about the artificial intelligence and machine learning. Working of Navy base. This computes the probability of each class given input features. Select the class with highest posterior probability. Model estimates probabilities from training data. It handles missing data effectively. Training is fast compared to other classifiers. The independent assumption simplifies computation. This makes the model scalable to large dataset. It is suitable for real-time applications. Navy Bayes model. It is simple probabilistic classifier. It is based on Bayes theorem with strongest independence assumption. Features are assumed to be conditionally independent. Give the classes. Despite this classification, it performs well in practice. Navy Bayes is efficient and easy to implement. It works well with high dimensional data. Common applications include spam filtering and text classification. It is widely used in machine learning. Actually, Navy Bayes model or the family of probabilistic machine learning algorithm based on Bayes network. They are called Navy Bayes because they assume that features are conditionally independent. Give the class label as assumption that is often unrealistic and works surprisingly well in practice. Core idea, let it be p of c by x, infinity to p of c, pi base I equal to 1 to the power n, p of x I by c. P of c is the prior probability of class C. P of x I by c, its likelihood of features xi given class C. Class is the highest posterior probabilities chosen. Actually, we need to know why it's called naive, because it assumes every feature is independent of every other features given in the classes. Example, if in the spam detection naive Bayes assumes the presence of the word free is independent of the word offer, give the class spam. Actually, there are types in Navy Bayes model. First one will be Gaussian Navy Bayes. Second, multinomial Navy Bayes. Third, Bernoulli Navy Bayes. Okay, these are the three types. Gaussian Navy Bayes is nothing but used when features are continuous. Assume features follow normal distribution. Okay, application, it will be used in medical diagnosis since our data real valued inputs. And then multinomial Navy Bayes, it's used for discrete count data, common in text classification. Applications of multinomial Navy Bayes use techniques is in spam filtering, document classification, and sentiment analysis. Bernoulli Navy Bayes, nothing but features a binary given as zeros and ones, represent presence or absence of features. These applications used in text classification with the binary word occurrence. Navy Bayes algorithm has 5 steps. First, it identifies classes from C1, C2 to Ck. Calculate prior probabilities P of C of I. Compute likelihood P of X of J by C of I. Apply Bayes theorem. Choose the class with maximum posterior probability. Okay. Simple example, let it be conceptual. Suppose class is equal to spam command not spam. Advantages of Navy Bayes model, nothing but simple and easy to implement, fast training and production, works well with high dimensional data, perform well even with small data set. Applications in AI like email spam detection, text and document classification, sentiment analysis, medical diagnosis, and recommendation system. Moving on to probabilistic reasoning model, represent uncertainty explicitly. They uses probability distribution to model variables. This model can combine evidence from multiple sources. They support inference in production tasks. Example include Bayesian networks and Markov's model. Such models are flexible and expressive. They capture dependencies between variables. This improves decision-making accuracy. Then moving on to Bayesian networks. These are graphical models for probabilistic reasoning. They represent variables as node and dependency as edges. Each node has a conditional probability table. Graph structure encodes conditional independence. Bayesian networks simplify complex probability computation. They are intuitive and visually interpretable. These networks are used in diagnosis and planning. They are a key tool in YAN. Moving on to structure of Bayesian network. Bayesian network is a directed acyclic graph. Okay, nodes represent random variables. Edges indicate direct probabilistic influence. Each node depends on its parent. This structure reduces complexity. It allows modular representation of knowledge. The network encodes causal relationship. It supports efficient inference. Actually, see this structure of Bayesian network represents set of random variables and their conditional dependencies using a directed acyclic graph. It is widely used in AI for reasoning and decision making under uncertainty. Main components will be nodes, random variable, directed edges, arcs, directed acyclic graph, conditional probability table. Okay, four components are there. Nodes. Each node represents a random variable. Variable may be discrete or continuous. Example, rain, traffic, or accident. This comes under nodes. And then directed edges like arc. Directed edge from node A to B indicates that A has a direct influence on B. A is a parent of B, okay? Directed acyclic graph. The network has no cycles. You cannot start at a node and return it to by the following directed edges. Conditional probability tables. Each node has a CPT that quantifies the effort of its parent. If a node has no parents, it reduces to a prior probability, okay? Example P of traffic by rain. Then moving on to formal structure of Bayesian network consists of DAG, jets V, E. V will be the set of nodes, E will be the set of directed edges, okay? And then we have the set of conditional probability distribution also. And then we'll be moving on to parent-child relationship. See, let us discuss about parent means direct cause of a node, child node influenced by parent, root node node with no parents, and then leaf node node with no children. Okay. Example structure of simple Bayesian network. See, if rain moving on to traffic, moving on to accident, rain will be the root node and traffic will be depends on the rain, and accident depends on traffic. This is the corresponding probability P of rain, P of traffic by rain, and then P of accident by traffic. Okay. Conditional independence. Nothing but structure of Bayesian network encodes conditional independence assumptions. A node is independent of its non-descendants like its given its parent. It reduces computational complexity. Okay. Common structure patterns also available, which is given in the method of chain structure. For the common cases and then call it a common effect. Okay. Chain structure, which is be moving on to A to B and then B to C. A and C are conditionally independent given B. Fork will be common cause, which is moving on to B to A and then B to C. A and C become the independent given B. Collider, which is given as the common effect A to B and then C to B, where B is observed and A and C are independent unless, okay. Advantages of Bayesian network structure: nothing but compact representation of joint probabilities, handles uncertainty effectively, makes causal relationship explicit, and then support efficient inference. Okay, moving on to exact inference in Bayesian network. Exact inference compute precise probabilities. It uses algorithm like variable elimination. Exact method guarantee accurate result. However, they can be computationally expensive. Complex network increase time complexity. Exact inference is suitable for small networks. It is used when accuracy is critical. This method provides reliable conclusion. Then moving on to variable elimination. It is an exact inference algorithm. It removes irrelevant variables systematically. The algorithm reduces the computation space. It works by summing out hidden variables. Order of elimination affects efficiency. Proper ordering improves performance. This method is widely used in Bayesian network. It's balance the efficiency and the accuracy. This is known as variable elimination. Thank you.